the derivative lab, no more than 4 in a group, and put your names on the front copy. And it needs to be neatly written, and you can cut the graphs. When you look at the document, there's a graph here. You can, well, I don't know if you can cut it, but I'm going to put it up online so you can actually take my pictures and actually copy them right into yours if you want. So it'll be online, so yes, you do have the pictures, and you have the chart and everything. So that's easy. If you know what you're doing, it's easy to do. It should be clearly written, put together like a formal lab, not little pieces, a little piece of a scratch paper here and there. What's going to happen is I'm going to send it back to you and I'm going to say redo this because it's not okay. Pretend this is your job and you're submitting a report to your employer. That's the way to look at it. Include complete sentences. You should include a sample calculation for calculations you do. You'll have to show your work on some things when you actually do the analytical solution. If you do not follow these directions, your report will be returned to you to make corrections. I've done that every year. And this is a little cartoon, and when you read through the problem, you can't even see it up here, but when you read through that problem and you read through the derivative, I happen to click on that little piece of clip art first, just by accident, but it fits. So we're going to do this lab, and this hopefully will tie into what you were learning about derivatives, actually, in 2.4. That's what those were. Okay. So here are our goals, and things are still a little bit of a mess. Or I didn't copy it very well. Probably that. I guess that's okay. We want to develop the definition of a derivative, and a derivative is the slope of the tangent line. Okay? You guys? You're going to define the slope by zooming in, so you're going to have a geometrical solution for each of the functions. There's 3. We'll do the x cubed one together. So you get the geometrical one, and then you're going to do it numerically. They really are the same. This is you actually calculating the slope by finding 2 points really close together, by zooming in until the function looks like a straight line. And so it's just looking at points on your graph. That's all it is. And then we're going to also learn how to do it with this n-derived function on our calculator that you all have. Now, if you have, I'll demonstrate with both the new operating system and the old operating system. Because the new one, once you see the new one, you're going to want the new one. Once you find somebody with a new one, you can just link it. I can't do that with the Inspire, though. I have to actually go through the Inspire stuff. And then we're going to do it analytically. So you have 3 functions. You will do all 3 of those things for each one. So it's 9 things. So in summary, and like I said, if you have any corrections how I wrote the thing, it's welcomed. It took me about 3 hours to actually type this up, even though I was working off a document, but I had to redo it because I didn't like the way it was presented. There are 3 approaches to each problem: the geometrical, analytical, and with a calculator. And you guys know what slope is. I'm not terribly concerned about that piece. At least we should all have checked that on our anticipation sheet, that we know what slope is, right? So what else should you be able to check? You should be able to build a table of values. I'll show you quick ways to those calculations. I'm hoping you know what a secant line is and what a tangent line is. And now that we're talking about that, see, if you have a circle, and here's your tangent line, okay? A secant line does this. This is a chord, so a secant line cuts off a chord, joins any 2 points on the circle. Well, in a graph, I think I should label that. I forgot to do that. This is the secant. And the tangent touches in only one place on a circle. But is that possible? Or is it possible for the tangent line to actually intersect my graph in another place? So I'm going to draw this tangent line right here. Is it possible? Yeah. Even if I slide it a little bit, I can make this. Whoa. What happened there? Must have let go. Cut. And what we'll do is we'll fix this guy. So it actually does this. So yeah, it's possible for a tangent line to touch someplace else. So that sometimes has been an AP question, one that you easily can get wrong because you think it only touches in one place. It only touches in one place in its neighborhood. We're going to talk about neighborhoods, but when I'm really close to that point, in that neighborhood it only touches in one place. It won't touch two places on the graph. When you're looking, you're zoomed in on it, it'll only touch in one place. But later on it can cross. So that's one thing you have to think about. Okay, so let's go back and see where we're at. We have slope, and we're going to zoom in. And there's my graph. And do you remember that this is called the secant line? Just like on a circle. So we need to know that. So hopefully now you can check that off on the other side that you know that. And I want to find the slope. So who would like to come up and find the slope of that line for us? Come on. You're going to need some ordered pairs. I'm going to move this over here a little bit. And yeah, you can take these pictures. Actually, you can take them off the smartboard once I put them up there, since I have them up this way. Oh. So she has to find the ordered pairs. And we should all be able to do this. I'll find out, because you know what I'm going to do? I'll give this question to my pre-algebra kids after we get to slope. As we get the slope in pre-algebra, we're only doing order of operations. Where some of you, I wouldn't laugh. Not everybody's got it down here either. And she's doing it nice and neatly so we can save this forever. Notice how she has the use of parentheses. Really, anytime you substitute, you must put them in parentheses. If you don't see parentheses in a problem, they're not there. They're not invisible. We're not hiding them. They're just not there. So don't assume that there's a parentheses there. If you don't see it, it's not there. And so when you substitute, the only thing I would say is if you really want to show the substitution, we put a parenthesis here, and now you can see slope very nicely. And that's the slope of the secant line. Well, what we're going to do is we're going to put a point on the graph here, and I give you the specific values. What is h? H is the distance between your x coordinates. And so we're going to take that point, and we're going to drag it, whoops, not that one. We're going to drag it down the curve. You want this to get closer and closer and closer to A. So what's happening to H? It's approaching 0. So this is the average rate of change. Let's get that labeled so we know that. And this is section 2.4. So what should you do? If you haven't done 2.4, I guess that's what you probably should do. And when we get through what we've done here today, I think it will help you a little bit with 2.4. Plus, the solutions are online. I don't want you to copy them, but if you get stuck in a problem, go and see how it's done. You still may not know, but that's okay. It's not okay when we're at the end of the chapter. So what are we going to do? We're going to do f of a plus h. So I'm answering another question that's in your lab. F of a, not an f prime, just an f of a. And that was just a pen mark. And what are you going to do? You want h to what? Go to what? 0. So we're going to do this with first numbers. And then we'll let the calculator do it with numbers, and then we'll actually do this. This is the analytic piece. This is the part you don't like, because this is the algebra. Actually, algebra is more than that. Algebra is really mathematical reasoning. So that's what algebra is. People think it's just about manipulating x's and things like that. No, it's not. It's the whole process of thinking. And it might be graphing, might be looking at a table, it might be doing the geometry. So all of this is algebra. So we're going to go ahead and look at the geometry piece. The first thing we're going to do is we're going to actually look at that, and we're going to zoom in on that point. So let me get my calculator up. Now, if you have whose calculator? I have so many cords. I have these cords. These might work, No, but I've not. Oh, here's one that will work for sure. Okay, that won't work for sure. Okay, so I'm going to bring my calculator up. And I'm going to show you a lot of cool things about this. We're going to go to large screen, and I'm going to clear that out. And let's graph this function. I already have mine in there, so you should have your calculator and put it in there. And it's actually faster to link it. Then, yeah, so if you link it with theirs. And so I'll show you both ways. So in Y1, I put that. Now I'm back to the new operating system. What I'm going to do is change it to classic view because most of you have classic view. So I just go under mode and I go down, and you probably aren't aware of a lot of the things. This is graph tables. This is like it's a split screen. I never use it because it makes my screen too little. So I'm going to go back to classic mode. These are the fractions. So I'm in fraction mode, but I changed my answers to auto. If I select fraction, all my answers will come out in fraction form, and I found it rather annoying because I actually want decimals. Because I can't compare fractions easily, can I? I'm better off comparing decimals. That makes sense? So sometimes I do want fractions, but sometimes I don't. And actually, surprisingly enough for me, I don't want fractions. So we'll do auto, and everything should be fine. I'm going to put it in classic mode so it looks more like yours. And then I'm going to second quit, and there's my y equals. Oh, that's still not. I have to write TI and tell them about that problem. Okay, and I always zoom 4. And now we're preparing for the exam also at the same time. And I always tell you to zoom 4. Zoom 4 or zoom 6, and if you want to do a zoom fit, that's fine. It doesn't always work. I rather just think about the problem and figure it out. So I'm going to zoom 4, and why do I do that? If I do a trace, I get nice numbers. I get really nice numbers, points. These won't necessarily be nice. But the problem is if you were asked to graph a function, and that's what you saw on your screen, and that's what you wrote down on your exam, you'd be in trouble. You wouldn't get the points. Because what's the function? What kind of a function is that? Not trig. It's what? It starts with a P. Oh, great, we're doing better. Polynomial. You got to know the vocabulary. And we know polynomials never have breaks in their graph. So what does that tell me about my picture? It's not tall enough, right? Now, you could do guess and check and see if you get the function, or you could go here and go second table set, start at 0. I always start at 0, and count by ones, and then look at your table. So you can see it drops down to -2, so I'm okay with my window there, but if I go back here, it goes up to 8. So what I'm going to do is change my window on the y values and make it go up to 8, or 10 actually. It has to be a little bit bigger than that. And now I'm going to get the full picture. And there it is. So go ahead and put that in there. But we want to actually look at, we want to zoom in on this point. So I'm going to go back to my calculator, and have you done any zooming? Now, to do a trace, I press trace, and I could do this, and I've got nice numbers, so I'll get to where I want. It's not a problem, but I'm lazy, and I want to actually find the value at 1. So I'm going to type in 1, and it will, whoops, 1, and press enter, and it will go there. So if you didn't know that, if I want to do a trace, now I'm in trace mode, if I wanted to look at -1, press enter, and we'll go up to that point right there. So if you didn't know that about trace, you don't have to arrow. You can just press 1. I'm in trace. You press trace, and you just press 1. That's all there is. And it will go to that point. Okay, so we're going to zoom in on that. So I'm going to press zoom and zoom in. Somebody would like to operate this, so, and I didn't do anything because I forgot to press enter. It's like a typewriter. Does that look like a straight line yet? So guess what? We got to do it again. Well, that's the problem. You guys turned it in, you haven't zoomed in enough. Same when you do the sine function, and the other one, I forgot the other one. Yes, we did 1, and we are doing 2. I might have missed the 2. By the way, there's a typo on page 2 at the very top. Whoops. No, just trace it. Trace. There it is. No, you're doing fine. Now, that looks pretty straight, or you want to zoom in again. Be careful not to zoom in too many times, because then the graph will become corrupt. The only way to describe it, so we're going to zoom one more time, just to make sure that we're okay. And, oh, that looks really straight, I think. And now, we're right on here. I'm going to press trace. I want to be right on that point. Okay, so that's one of my points. And actually, this is question 2, and I think it's down further on my smartboard. Now, I want to get another point. So, you know what I'm going to do? I'm going to press trace. I want it really close. I'm just going to press the right arrow button and get another point, and there it is. So there's my other point. So I've got 2 points there. We're going to remember this. I guess it didn't, oh well, it's missing on it, but anyway, that's okay. Okay, and I just want to find the slope, and you know how to find the slope, right? M is equal to, well, which number do you want to put in first? The -2 or the -2.00018? -2, doesn't matter. Minus, and then it's -2.000018, but I'm going to show you an easy way to do this. Here's your sample calculation, by the way, and then the x value that goes with -2 is 1. So if you look at the very top of that second page, right by the question 2, I have the signs reversed by accident. I will fix it before I put it back up online. And then this is 1 point, no, how many zeros is there? 5? Okay, I don't want to type that into my calculator, and I'm not going to. Not going to. Watch this. If you haven't learned this, you want to learn this because it's going to come back and help you later on the exam. I'm going to quit from my screen. Notice the numbers that are there. And if the calculator remembers where you were. It remembers where you were. So if I type in X, there it is. No, that's with all of them. This works for all of you. And it also stores the Y. So wherever your cursor last was on the screen, that point is stored. You're going to be looking for intersections of curves, and you want to store this. Now, that part of the exam has now shifted to the non-calculator part. So you'll have to be able to find intersection points by hand. It used to be in the calculator part. But that's the way it goes. Alpha, and the reason they had to change it is because I think the new Inspire can actually do the calculus, can actually set it up for you. You just have to show what area you want to find the area of, and it will do it. So they had to take it off the calculator part. So there they are. Now, do you believe that the ordered pairs are there? All I have to do is type my slope formula in. So my slope formula is, I'm just going to type it in. It's parentheses. It's the y value, alpha, y, subtract the y value. What was the y value that we know that was an easy number? -2, right? And I can see slope. Now, if I were in the new operating system, I'd see it even better, and I can show you if you'd like. Divided by parentheses, and then it's x minus 1, right? So that's the point we started with, and this x and y is not just any x and y. It's not a variable. It's whatever was stored. It's these values right there. And all I have to do is press enter, and there it is. Now, that's just by zooming in. I think if I zoomed in a little closer, maybe I get a little better. When you give me answers, I want all the decimals. And that's because if you give me what the limiting value is and not these decimals, I'm not going to believe you did it. And, you know, you can do this. You can, well, you have to have Smart View. You can do that and take the pictures like right off if you want. That's fine, whatever. So that's kind of cool that I can do that. Now let's look at it because I want to. Oh, I got to change my operating system. I have to change my mode though. This is a pain. There is no other way to do this. Okay, I'm going to go to Pretty Print, Math Print. And now I'm going to put this slope in, but I'm going to go through fraction mode. So it's a fraction, numerator, denominator, and this is whoops, I did it. I've been doing that all day. Parentheses, and it's y, should work nicely, minus a -2. I'm not even going to take the chance of making a sign error. Oh, I don't need the parentheses there. But I haven't. It's okay. X minus 1. Now that looks like slope. And there you go. So if you have the new operating system, now a couple people do, it's you have to go alpha, and y equals gives you the fractions. 2 gives you a mixed number. That's the units place, numerator, denominator. 3 changes an improper fraction, like 3/2, to 1.5, a mixed number. And 4 changes from fraction to decimal and decimal to fraction. We can try to do 4 on this and see if there's a fraction. See if it works. Sometimes it does. Oh, no. And sometimes it doesn't. Too many places. So that's the way that goes. But that's kind of nice. And here's the other thing with the new operating system. I want to go back up here. I want to use this again. Press enter. And you know what? I'd like to get these parentheses out because I don't need them. I did when I wrote it in the other fraction mode. Enter. There. Now you can really see slope. It's really very nice. Okay. That's the geometric piece. You have to actually zoom in on your curve so it looks like a straight line. I'm giving you lots of answers here. By the way, it's a summative, 32 points. Well, yeah, but you should have question 1 right. If I see 1 wrong, I'm going to be upset. Except for the seniors, because they're not here. But, okay. So now, this next piece is a little confusing, but it's not that bad. I want to sketch on that graph, so I'm going to go back and copy it. This one. And I'm going to paste it in. Okay. There we go. Perfect. And I have my table of values. So what it wants you to do for each value of h, now remember h is the distance from here. So if I do, h is 0.6 because I give you the values somewhere, right here. The first h value is 0.6. So you're starting at 1 and you're going to go over h. So you're going to be at f of 1.6. I'll show you how to easily get this off your calculator. So 1.6, actually we can do this on this graph. There's 1, 2, 3, 4, 5, 6. So it's down here. And it asks you to draw the line containing them. And except that I got to fix my line. No, I don't want to translate it. There it is. There's my secant line. Don't give me segments. Give me lines because you won't get the patterns otherwise. And then I'm going to do it for 0.4. It's that in pink. So I'm going to start here and go to 0.4, which is somewhere around there. And you can cut it right off of your paper if you want. Well, come on. I want that. Looks like that might be about there. Okay, so you're going to put in all these lines, all of these. And we're going to find the value of f of 1 plus h, and we're going to find the slope. How do you find the slope? What slope? It's f of what? 1 plus h minus f of 1 divided by 1 plus h minus 1. And I know it seems silly to put those parentheses, but I see slope when I put them there. So m is equal to f of 1 plus h. So here's my example. That's my sample calculation. Because once I show you how to do this, you don't want to write all the steps down because it's really fast and easy in your calculator. minus f of 1. And we can actually do f of 1. Let's do that. I know it's negative 2, but I might mess up my signs. And the bottom number is h. What's h, though? It's 1 plus 0.6 minus 1. You guys don't like to do this. Simplify. What's 1 minus 1? 0. Okay. So this is just going to be 0.6. Okay, ready? We're going to get our calculator out. We're kind of there because I already have it there. Now I'm in pretty print. Oh, maybe we should just type it in. Let's just type it in. Okay, so I want f of 1.6. Now, I got to get y1, and there's two ways to do it. In the old system. So we'll do this like we're on the old system right now. I'm going to need a parentheses, and my y1 is in vars. We have to know where it is. If you're in the new one, it's a lot easier. You go alpha, and you press the trace button, and there's y1. So it's done. But we're gonna forget that we know that, and we don't have the new operating system because we have a TI-83. So how do I get y1? You press vars, and it's actually easy. It's always the first choice. First you have to go over to the y variables, and then it's a function. With me? And there it is. It's not that hard to get, but you need to know it. So I want y1 of 1.6. This is one way. I'm going to show you another way because I just thought about it. Minus, whoa, too many minuses. y1, so I'm going to go vars. It's a y variable. I don't ever do anything with anything there. Not in this class. Function y1 of 1, right? And then close your parentheses divided by h, which is 0.6. There it is. I'll show you another way, though, just because it's really nice. What happened to it? Ah. There it goes. So there's a variety of ways to do this, but there's actually even an easier way. So I'm going to go back here, and we know that it's the y value. What was our y value again? Remember where it was? Alpha y. There it is. So I'm just going to set it up. Parentheses, I want y, alpha y minus, and we know the y value there, it's what? Negative 2, right? You could do y1 of that if you want. This is actually taking the point we found on our graph. Close your parentheses, divided by parentheses, then it's the x value minus 1. Now, oh, that was this y value. Oh, so that's going to get me really close. But now let's go back here. Let's go to our graph. Oh, we got to go back to the original graph. So you know what I'm going to do? Zoom it 4. I'm going to change my window to 0, and I'm going to make this y max 10. So we could, well, I don't even need to do that. That's the only part I care about. Okay, so I'm going to trace, and I'm going to do 1, and we'll start where that's going to be, and then I want to go over to where? 1.6, right? 1.6. This will store the value there. So this is what's going to go in your calculator. So if I quit, second quit, and I type in x, there's the 1.6. If I type in alpha y, there's the negative 2.54. Now, you can go second entry a number of times to get back here. I can just go back. That's what I'm going to. It's the same time. And now it has the x and y. These latest x and y's are in here, and you press enter, it'll give you that negative 0.84. So you say, well, how is that faster? Well, it is faster because what's your next h value? In your chart, look in your chart. Is that my chart? Okay, so this was, and I actually know what this is. It's negative 2.504. That goes right here. Negative 2.504, and the slope is negative 0.84. It's not asking for just the y value. It's asking for the slope between that and 1, negative 2. So what's my next h value? H equals what? Right here, it's 0.4, right? And so where am I going to be? I'm going to be at 1.4. So I'm going to take my calculator. Now, I've got my sample problem. I don't have to show the work anymore. Just write your answers down. That's all you have to do. So I'm going to go back to my graph, and I'm going to trace. There are a variety of ways to do it. I want 1.4. Enter. There it is. Okay, that's all I did was I traced. I've got it. Now watch. This is so easy. I'm going to go back up and grab this little slope again and press enter, and it will automatically take the new values and put it in. So what's the next value you want to do? Trace. I'm at 1.4. What's the next one? 1 point what? 1.2. Whoops, got to press enter. Okay, that's stored in there. I go back to my home screen. I just go up, or second entry. See, I don't have to do all that work. Who cares? So I'm showing you some quick things on your calculator that will help you along throughout the rest of this course. You can do all of this, yes. Now, what you can do, on an 83, you have to go back and hit second enter until you see that again, and then you just, yeah, so it's nice. I'm going to save this nice, pretty little screen here, and so you've got some answers. You've got a lot of answers. You might, just for yourself, you might want to just go back and do this for the sine function. This particular question, you do not have to do for the sine function and the other one that's there. Just the one has you do this. Now, that was the geometric one. That's what we got to do. You got to answer the questions at the bottom of the page, okay? And then you have to do it analytically. I am sorry that this has really messed up. But you remember what you're going to do? It's the limit. And what's my value? What's my a value? Starts at 1, right? So it's f of 1 plus h minus f of 1. That's the definition of a derivative. I don't know why it's called derivative. Might look it up. And I don't know why an integral is called an integral. It's an antiderivative. But why derivative is there? I don't know. So guess what you're going to do with this? You have to do this. Now notice f of x looks like this. So it's the limit. I want this set up so you at least can get this right, because you might forget the 3. It's x, but what's x? What's x? Okay, I'll put another goal. We learned function notation. This is the x. This is what you're going to put in for x there, and there, and there are no x's there. So you could put that in for x to the 0 power, which is just 1. So I'm going to put in 1 plus h, and guess what this is? All of this is simply this one. Then I have to do minus f of 1. What's f of 1? Remember it went through what ordered pair? 1, negative 2. So what's f of 1? Negative 2. Not that hard. All over h. Do you remember how to expand 1 plus h? Remember Pascal's triangle? That's the 0 power. This is a plus b to the first power. Those are the coefficients. And then you do a plus b quantity squared. And remember how to get this? You add these two. 1 and then 3, 3, 1. You can go on, but I just gave you your coefficients. So, now if you have a CAS calculator, the 1 plus h you can cube very easily on your CAS calculator because it does it. What's interesting about Pascal triangles is they have a whole book about it. And I went to a workshop and we just did a little problem. And I'll bring it in because it's kind of a neat little problem. It's a cube. It's an n by n by n cube. But first you start off with, 1 cube. And then you do 2, 2 by 2 by 2. And then you do 3 by 3 by 3, etc. And what's very interesting about this is we're going to paint the outside. And you count up how many faces. How many cubes have 1 face painted? How many cubes have 2 faces painted? How many cubes have 3, etc.? You do that, you count them up, and what you will get is Pascal's triangle. You'll see the binomial theorem. Now you got to think about that. That's a purely mathematical abstract concept. This is a concrete thing. If you actually cut this up, dip it in paint, that's what's going to happen. You're generating the numbers generated by Pascal's triangle. So even though people made up the math, it's still in nature. You can't just make up anything because it is part of our world. Yeah. You're going to dip it in whatever. So if you have 3 by 3 cube or something like that. 1, 2, 1, 2, 3. And you dip it in paint. How many faces have just one face painted? Yeah, this is going to have 2, right? You have this one and this one. Some of you are more kinesthetic learners. You want the cubes in front of you and you want to count them. I'm kind of that way, but I can do it without. This only has one face painted. How many faces will be painted on this if you dipped it in? There's things you don't see. There are 3 because it's a corner. I'll bring the cubes too if you want. You just got to find them. And you get Pascal's triangle. I'm the only one that sat at that math workshop and saw that. And I got really excited because I saw Pascal's triangle. This was amazing. Okay, we got to do one other thing. We did the analytic one. And, oh, you have a quartic and you have a sine. So you're going to do this stuff. You don't have to do the drawing the tangent lines and finding the slopes, seeing how they go in there, unless you want to. But we have to do the calculator piece. Except you want to know how to do the calculator piece.
Well, I can watch it.
Okay.
Let me figure out.
Yeah. There it is. Oh, yeah, your calculator's done. Okay. We are going to do this. I tell you how to do this, and I give you some ways to do it. I give you the old way, and I give you the new way. It's all written in here, but let's do it. Because this is cool. You have to know this on the exam. Amazingly enough. I'm going to clear this. Now, we're going to go back to our graph. Here's the first way, and this is true for all the calculators. You want to do second calculate, and that dy dx is our symbol for derivative. Now, we say dy dx. That is not correct, but everybody's lazy and we say it. It really is the derivative of y with respect to x. The with respect to x is critical. We'll get there. We're not there yet, but right now, you're simply going to think of it as dy dx. Isn't dy dx delta y over delta x? So when you make delta x really small, we call it dx. Delta y really small, we call it dy. And one person in my, when we used to teach the NSF materials, and we did all problem solving, one person actually called delta y delta x dy dx by accident, and I said, yes, when you make h go really small, you're talking about a derivative. So we're going to press 6, and then you want to tell it where you want the derivative. We want it at 1. And there it is. The problem with this, there's a huge problem with this. I want to do the derivative at 20. My window only goes to 4.7. So I'm going to go second, calculate. We're going to do derivative, and we're going to do it at 20. Plus, you have to figure out the window. You're in the middle of the exam. You need to find a derivative with the calculator, and you will be required to do that on the exam. And if you go to the graph, it's fine, but you've got to fool around with the window. I don't want to do that. That's too much work. So there's a better way to do it. So second quit, and it's under math. And we're going to go down to n derive. Now I'm going to give you pretty print first because that's where I'm set. If you have the new operating system, you can do it this way. But watch how pretty this is. This is the way it actually looks when you actually start doing derivatives. This is the derivative operator. There's an x. You have to say what the variable is. Like if you do perimeters, twice the length plus twice the width. Which one's the variable, the length or the width? You can't have two. You have to tell it which one you want it to be the variable. And then I want the derivative of y1, because that's where I stored it. Now, I have the new operating system, so I'm going to cheat. I'm going to go alpha. There it is. Just pick it up. So much easier. And where do I want it? I want to do it at 1. And when you learn the symbols for this, this is the easy way you really want the system if you can do it. And there it is. Okay. Now, what I'm going to do is, first, before I do that, I'm going to show you that you don't have to go under Math Menu to get that. You go alpha, window, and there's absolute value. Sigma we don't use in this class. There's the derivative, there's the integral, and there's your change of base. So it'll evaluate any log, any base. So you can do n derive that way. You'll see exactly the same screen. So let me go ahead and pull that off. Now, I'm going to go back. It's going to take me a second, which is why I don't like doing this. I'm going to go back to the classic mode because most of you are in that mode. And this is what you will see. So there is no, you don't have the function key. So even though I still have them, you don't. So we're going to go under math. and we're going to go down. It's 8. You will eventually memorize it, and we may store it on your calculator. We'll put it in Y0, then it'll be at the bottom. Don't turn it on, just leave it. You'll have your syntax there, and then all you have to do is evaluate Y0. I could show you, but I don't think I have time today. So now I need Y1. We're in the old calculator, so we have to go to vars. It's a Y variable, so I got to go over. It's a function, Y1. Then you have to tell it what the variable is. And for what you're going to do in this class, it's always going to be X. So just always put it there. You get a syntax error if you don't. The calculator is looking for that. And at what value? I want it at 1. In fact, you can even tell it the H value if you'd like. I've never done it. Your book tells you how to do that. And so we press enter, and there it is. So that's what you're going to do. I personally like the pretty print better. I like this guy. How about you guys? So what are you going to do? You're going to, for the rest of ooh, time to go. But you're going to do the next 2 problems. You don't have to do all that stuff with the beautiful pictures. But you do have to zoom in on it geometrically, like we did. Zoom in, get it to look like a straight line. Then you have to do the algebraic solution, the part with the limits that you don't like to do because it involves algebraic manipulation. And then you use nDerive. And then there are a couple other questions to answer. The more, you can form your group, so the more you do over the weekend, the less you have to do next week. Now, Monday will be a class period dedicated to you working in your groups in your lab. I will not be here. So should I put the video into the subfolder, and we can show the video again if need be?
I'm not going to be here Monday, so should I just do this by myself? Because I'll only have 1 day in my group, and if I don't do it by myself.
Oops, I don't want that.